Hello, everyone, and welcome to today's webinar, Do More with Less, How Finance Leaders Can Improve Cost Efficiency and ROI with AI. My name is Elsa Mann, and I'll be your moderator for the session. Just a few housekeeping items before we get started. This session is being recorded, so you'll receive a recording afterwards so you can rewatch it or share it with your team. You should also see a Q&A panel on your screen. Feel free to drop in your questions at any time. We'll leave some time at the end to go through them live. And if you run into any technical issues, just let us know in the chat and our team will help you out. In today's webinar, we'll explore how finance leaders in manufacturing can use AI to uncover hidden costs, connect operational performance to financial outcomes, and turn continuous improvement into measurable results. Now it's my pleasure to introduce our speakers today, Jesse Aust and Zeeshan Zia. Jesse is our VP of Revenue at Retrocausal, who brings over 20 years of experience across manufacturing and enterprise software. His experience spans from the shop floor to enterprise strategy, helping manufacturers turn operational performance into real business results. We're also joined by Zeeshan, who is the CEO and co-founder of Retrocausal. Before founding the company, he led AI projects at Microsoft HoloLens division and Siemens, holds nearly 20 patents, and has published widely on computer vision and machine learning. And with that, I'll hand it over to Jesse and Zeeshan to get us started.
Thanks, Elsa, and thanks everyone for joining today. Excited to hop into this and bridge the gap between the shop floor and finance leaders, and get you guys some cost savings. So what we're going to talk about today is a couple of things, but the overarching theme is, and the reason why we wanted to have this specifically for finance leaders is I've probably worked with 700 or 800 manufacturing companies over the last 3 years. And one of the biggest, it's not an issue, but one of the biggest things that I've recognized and that's been brought to my attention, not just by my observation, but by the customers that we work with, is that the finance leaders, they wait for the solutions to be brought to them by the shop floor. And what you have is the question of most of the finance leaders tell the manufacturers on the floor, you need to explain to me why we need to spend money on this. And what we'd like to do today is talk about the vice versa of that activity and have you have visibility on the tools that are available and have you have the ability to go to your manufacturing floor and say, why are we not using this? And I think that will bridge the gap and speed up the process of adoption in your company of utilizing AI solutions that can drive ROI and impact the bottom line from the day it's dropped into the manufacturing floor. And so that's what we'll talk about today. I'm going to have Zeeshan talk a little bit about some of the challenges that we face in the industry, and then we can talk about product. So Zeeshan, I know my screen's shared. I can go ahead and just manage the screen if you want to move through it.
Of course. Thanks for that introduction, Jesse. This makes a lot of sense. Everyone, I'm Zeeshan. I'm the CEO and co-founder of Retrocausal. I come from a pure technical background to complement Jesse's background, which is a lot more in finance and growth and those spaces. And as somebody from technology who has spent a lot of time on shop floors, working with industrial engineers, continuous improvement teams, a number of challenges that I see constantly are around production cost, especially with recent years, how reshoring has been happening. 60% or more of US manufacturers have been talking about reshoring manufacturing even last year, right? Even before the current government. And of course, tariffs are moving the needle further in that direction. That means that you need to bring your production costs down. You need to control your production costs, maintain the capacity without increasing headcount, maintain the capacity without increasing pricing on customers, while minimizing waste as much as possible. Waste in terms of operator headcount, waste in terms of shop floors, floor space, literal real estate, or whether it's waste in terms of excess inventory that you might be producing. Another trend that we see a lot in manufacturing, and that's going to become more and more prevalent as time goes by is mass customization, which means that consumers and customers are asking for more and more customization. They expect products that are almost personalized to them, and that is having an impact even for larger manufacturers. You're having to change work instructions. You're moving towards high mix, even if you traditionally were just high volume, low mix. That means that you have to revamp your work instructions constantly. There is lack of visibility. Uh, if you don't know what's going on your lines, if your leadership doesn't know what's happening, it's hard to manage that cost. So a lot of manufacturing leaders are asking for more visibility on what's going on the lines. A lot of IoT solutions have been deployed that help you figure out the state of machines, but still there is a lot that happens with humans and robots, and uh, there's not complete visibility there. You don't exactly know what's going on, what could be improved, uh, just by looking at dashboards today. And then to Jesse's earlier point as well, demand whiplash. Demand is getting even harder to forecast. And from month to month, this month you might be producing 100,000 units of an industrial heater, and next month you might be producing 60,000 units of that same industrial heater. And that, yes, there is an impact of that on the finance side, but it's also tightly coupled with the impact on the production floor side. How do you quickly make sure that you are not producing 100,000 units of that industrial heater when the demand has gone down? How do you rapidly adapt your shop floors in response to that demand whiplash? And essentially, a lot of traditional approaches involve just having continuous improvement engineers, uh, or manually trying to check what's going on the shop floor. Challenges include that these approaches are slow, time studies, line balancing efforts, these quality audits. These often require days and weeks of manual effort. So you're getting up-to-date information about every process maybe once every 6 months or so. If you have a team of industrial engineers going around a shop floor from process to process, they spend this week on a given line, the next week on the next line, so that you can gather data about the processes that are taking place on that line. By the time they come back to that station, all your data is completely uh, outdated, right? It's become inaccurate, and that's what the quotes you are giving your customers are based off of, right? So that's what's how you're computing your supply chain, your raw material needs. So all of those become inaccurate. Uh, there is, of course, a disconnect, has always been the case, of what's happening on the shop floor and the financial KPIs. Your industrial engineers are not financial engineers. They're not often trained adequately in finance metrics. So there is a need to bridge the gap between what happens on the shop floor and the financial folks. Uh, and then, uh, you know, traditional approaches, tools, even tech tools are pretty limited in what they can do. You can only monitor machines, like I alluded to earlier. Maybe you don't have visibility in what human operators are doing, how much rework is actually happening on the floor. It's really, really hard to track those kinds of numbers.
So that's what we're going to talk about today is, and basically, we're going to talk about a couple of different approaches. We have two solutions to the most common and impactful problems that happen in manufacturing today. We're going to talk about the metrics that provide and how those improvements from using our tools translate into financial outcomes. I mean, you can see a couple of the impacts that we have today, and we'll get specific between the tools. But reducing rework. Obviously, it improves gross margin, reducing waste and material loss, faster cycle times, increases throughput and fixed cost absorption. Ergonomic design obviously reducing injury-related downtime and workers' comp costs, stabilizing labor productivity, and automated studies. Cuts engineering overhead and accelerates the ROI validation. So you get that proof of the work that you're putting in, the proof of the changes happens a lot faster, freeing time and budget for higher value initiatives. So a couple of the things that I encounter on a daily basis in my conversations is basically it's the overall cost of manufacturing is going up across the board. The cost of labor is going up. The cost of quality is going up. The cost of materials are going up. The cost of supplies are going up. The cost of your power bill is going up. It's just across the board. And so what you're being forced to do, specifically from a finance perspective, is you need to maintain capacity either by using less resources or by reducing the cost to maintain that capacity. And that's what we're going to talk about, how our tools help and solve today. So the role of AI-powered visibility, allowing finance leaders to move from lagging to real time. And that's one of the things that Zeeshan talked about that is truly impactful, is because the dynamics of manufacturing are so much different than they were not several years ago, but just a year ago. And I'll give a specific example about why we built one of our tools based on those same dynamics. But going from lagging to real-time indicators, having you giving you the ability to switch on the fly, to pivot on the fly, quantifying hidden costs of inefficiency. And that's one of the biggest ones as well, is identifying where the waste is and how we can remove it immediately and quickly. And linking shop floor performance directly to P&L impact. That's another path that will guide you through and show you exactly how to track and impact those metrics. And then prioritizing initiatives based on measurable ROI. And when we talk about some of the challenges that we focused, we'll look at those at problem specific when we look at our tools, but we have very clear metrics that you can apply to your current operations that can quickly tell you, whether or not this makes sense. And then at the end of this, we'll share a couple of ROI calculators with you as well, so you can connect with your leaders on your shop floor and see exactly what the impact of these tools would be on your bottom line. Zeeshan, you want to talk about the power of AI, frontline workers, and then we can talk about those metrics quickly.
Of course. We are seeing AI being deployed to help frontline workers across multiple dimensions that affect the bottom line of the company. These include helping frontline workers minimize scrap costs, help managers reduce training times and assembly errors while improving quality and first-time yields. This includes AI solutions such as work instruction solutions, proactive work instruction solutions that can guide an operator as they're progressing through let's say an assembly line process. A camera or other AI systems can understand every step of a process, and if an operator is about to make a mistake, these systems can alert them to help them minimize scrap rates, minimize rework costs. And then post-assembly, these AI solutions record video data, they record analytical data to shed light on that very manual process that has so far been in the blind spot of industry, so that you can do root cause analysis. Why are products coming back from customers to us? How can we improve the process? Those kinds of things.
Yeah, and so thanks, Zeeshan. We were talking about the metrics and having the clear metrics, and this is why it's important to obviously bridge the gap between finance and the leaders on the shop floor, because it's important for everyone in that chain to understand where are we at today. How much does it cost to train a new employee? How much does it cost to increase our yield or not have the ability to increase our yield to meet demand? And how much is our scrap and rework on a monthly and an annual basis? If you have those numbers in hand, then you can quickly identify the kind of impact that we can make. And one of the tools that we have is called Kaizen Copilot. And basically, it is an AI vision system that error proofs and mistake proofs assembly operations. And the metrics that you can see with this tool is that within 12 months of deployment, we can reduce 90% of scrap, rework, and assembly related errors that occur at that station or on that line. we can provide you with a 25% increase in first pass yield and throughput. And then we can also reduce the time it takes to train an operator by almost 80%. Those are extremely impactful, clear, identifiable metrics that, again, if you have an idea of what those costs are currently in your processes today, then you can apply these metrics and build out that business case very quickly, along with the use of the ROI calculator that we'll share with you. So this is our tool, the Assembly Copilot. And basically, the Assembly Copilot is a continuous, always-on system. It's comprised of a camera, an edge device, and a monitor. And you deploy it at the station or at the line where the activity is occurring, and the system monitors the activity and ensures that the operator not only adheres to the standard operating procedure, but if they make a mistake or about to make a mistake, our system alerts them to that error so that they can rectify, fix that through in-process quality control. We also guide them through the process with digital work instructions, in-process task guidance. So we're guiding them through the process and then also verifying that they're doing it correctly. And again, we can reduce 90% of scrap, rework, and assembly-related errors just by having this system on the line. So we've got a video that we'll walk you through so you can see what it looks like in action. And Zeeshan's actually in this video, so I'm going to actually have him narrate you through it.
Yeah.
I'll go ahead and press play and you let me know if you want me to pause it.
Of course. So in this video, you see a display that's mounted in front of an operator. There's a little camera. Optionally, there can be a multimedia projector, often for our European and Mexican customers. You bring in a unit onto the station. The AI knows that you are now installing the fan into the unit, or that it tells you to install the fan into the unit is the next step. Once you've done that, it understands that you've finished that step, and now it's asking you to pick a washer and a bolt. But next you were supposed to install that washer and bolt, and you're doing something else, at which point the AI intervenes and there's that stack light optionally going red, and it's giving you that alert. Hey, you were supposed to install the washer and the bolt. With that, the operator goes in and installs the washer and the bolt, and the error message disappears, and the experience moves along. Now it's telling you to install the grill, showing you a video of the same. Again, the projection component is optional. And once you complete the build, the system signs off on that, and the video and the analytics for that cycle get recorded in the cloud.
Thanks, Zeeshan. And so when we're looking at this system, one of the common questions specifically from finance is, what is the cost to deploy this? What are the resources required to deploy this? And it also is a concern from the manufacturing floor. How long is it going to take us to get a system like this in place? Do we have to hire someone to manage the system? When are we going to start seeing results? And those exact questions are exactly why we build our tools the way we built them. They're extremely no code. We can teach someone to be an admin on a system in typically 15 to 20 minutes. It's point and click software. It runs on commodity hardware. So what you're usually used to seeing, which is that high CapEx cost up front for hardware to run on site, we eliminate from that equation and built the system to run on commodity hardware by having the heavy compute happen in the cloud. We can typically stand up a model in several days, where everyone else takes several weeks and several months. We can deploy this on your station in several days worth of work. And so again, you can start immediately seeing ROI. And you saw the metrics. Those are within the first 12 months of deployment. Typically, we can capture those in the first 6 months, and we have tracked 6 months payback ROI on the system from the time it's deployed at the site. So when we're talking about root cause analysis and process optimization, so not only do we ensure that the operator does the process correctly, alert them when they're making mistakes through that in-process quality control and task guidance, but we also aggregate all of the data that occurs during each process that we're observing. And so we're tracking things like cycle times, step times, sub-step times. We're tracking deviations from standard times. And what that does is, going back to Zeeshan's point about some of the challenges, the dynamics of changing process. right? So when you look at this screen right here, what is the average step duration? This is provided to your IE so they can log in and see this at any time. And you can see right here, this step 3 is almost 2x out of tolerance. So it's almost taking twice as long, actually 3 times as long to complete this step as it should consistently. So this is an on average metric. So your people on the shop floor can look at that and quickly identify, okay, this can be a potential bottleneck. It's already causing problems. It's slowing us down. Let's do root cause analysis. We'll pull up the video, see exactly why it's happening, and we can fix it on the fly dynamically. So it allows your team to be prescriptive and proactive in these fixes that end up when you've got something like this that's happening. Let's say you're building 5,000 units a day and you've got a step that's taking 3 times as long as it should. That fraction of a time error is going to add up over 5,000 and quantify into very impactful costs that are occurring on your bottom line. So having these analytics on demand for your team allows them to be prescriptive and be proactive and eliminate these issues before they become critical issues that actually stop production. And then from traceability, this is huge. Having the ability to trace a build down to a specific serial number, a SKU number, a barcode, a batch order, a work order, etc. We can tie unique identifying numbers to each video so that if anything happens downstream, you can source that quickly and again do root cause analysis. And so with the in-process quality control, we're eliminating 90% of manual assembly related errors. What does that equate to? Recalls, customer complaints, shipbacks, warranty claims, customer reputation impact. Those things also impact the bottom line drastically. And so we're looking at traceability. If you do have an escape, you can quickly identify where that escape occurred and why it escaped, and make sure that that doesn't happen again. And then this is a case study that we did with a medical device manufacturer. You can see the details here. And obviously this deck will be shared with everybody once we get done with the call. But from a scrap rate perspective, they had a challenge. They had a 30% scrap rate on this particular unit. Because it had to be built to spec, each time that they built a unit wrong, they had to scrap the entire unit. And that cost was $1,500 per unit. And you can quantify that over any number of units per day. And that's a significant margin hit that you're taking. And so the solution is deploying the Assembly Copilot, the error proofing tool, across 4 stations in 2 days. And we can do this before or after shift, on lunch, on the weekend. We don't impede on the production time whatsoever. And what we were able to do is reduce that scrap by 60%. So we took it from 30%, so 3 out of every 10 units, to 1.2 out of every 10 units, down to 12%. Now that units were being built consistent, compliant, and quality maintained, and if any of you are in any type of compliant industry and you get a letter stating that, hey, we've got a compliance issue, well, you can actually prove now that you are building to spec within compliance with that traceability that we talked about previously. So it resulted in an annual savings of several $1 million, which was, I believe, a 10 to 15x return on their initial investment. And then obviously it shifted from unpredictable scrap cost to predictable gross margin gains. I'll let you take this one, Zeeshan.
Of course. So essentially, I come from an industrial engineering background myself. The beauty of some of the tools that we are building, and more broadly that AI enables, are you're seeing a massive productivity boost for industrial engineers for a lot of the tasks that don't involve actual contact with operators. We are boosting their productivity by as much as 4x, which means that industrial engineers, your continuous improvement engineers, your operational excellence team, they get the opportunity to uh, actually implement those changes on the floor, work with the operators and make things happen on the floor. We are letting them perform time studies 6x faster. Ergonomics analysis are 80% less costly. Everybody can do ergo analysis. That helps you in further down. It helps you with OSHA recordables and any health and safety related costs. We are almost eliminating documentation costs when it comes to shop floor related documentation, while making sure that you maintain up-to-date documentation, as Jesse pointed out, for compliance purposes, but also just to have better data for quoting to your customers, for to make sure that waste is managed and all those things. And then being able to use AI that's specifically tailored to your shop floor processes enables a lot better internal collaboration within the same shop floor, but also across factories, so that you are better able to uh, propagate good ideas around process improvement from one factory to other factories, and see that benefit on a more global level.
Thanks, Zeeshan. So the tool that we're referencing as a solution to a lot of these challenges is called Kaizen Copilot. And so now we've got two tools that represent a closed loop system to where the Kaizen Copilot allows you to build your most efficient process. And once that process is in place, the Assembly Copilot provides process adherence to the operators on the floor and ensuring that the process happens correctly without mistakes every time. Now, the Kaizen Copilot specifically, to give you a more real world example of why we built this is we were working with a very large cell phone manufacturer, and one of their or a couple of their specific challenges was, one is every shift they had to rebalance the line based on operator availability. So it was a very dynamic environment. The nature of their product was dynamic in itself, in the sense that they were doing high volume quickly and it tapered down even quicker, and they were moving on to a different iteration. So work instructions, capacity planning, process planning, those were all things that were happening on the fly. And to top that off, their industrial engineers and CI team were having to do time studies, manual time studies and motion studies on the floor. And so through that dynamicness, the challenge was is they had no time to actually take any of that information and sandbox it to actionable, meaningful decisions. So the requests came from us that said, if you guys could build something that could automate some of that data analysis, some of that data collection and initial analysis, it would probably 2 to 3x the output of our entire engineering and continuous improvement team. And so that's what we set out to build. And in this video, we'll show you what we did is we went out and we took our existing vision technology and we built our own Lean GPT, which is manufacturing specific. And just so you know, we don't leverage any third-party models. All of our technology is proprietary. And we married those two technologies together. And so what it allows an industrial engineer to do is go down to the floor and use any commodity camera and automate a lot of these manual data collection tasks. And the reason why that's important is right now, from a financial aspect, you're paying an engineer's wage to do intern activities on the floor. So there's a big cost sink that occurs every time a Kaizen event occurs at a facility. And to give you an example, if you look on LinkedIn, it's a very popular post to post about Kaizen events, and you'll see a team of 10 to 20 industrial engineers traveling to a facility and basically spending 80% of the time doing time studies and 20% of the time doing analytics on those time studies. And what we wanted to do is we wanted to flip that ratio to where 20% was spent on doing that manual data collection and 80% was spent on doing the actual work that they became an industrial engineer to do, which was get to process and continuous improvement decisions. And so the Kaizen Copilot, this gives you an example of how you can use a cell phone, capture a video of a process, upload it to the Kaizen Copilot, and it will automate a lot of those manual tasks for you. Is that audio coming through? If it's not, I'll narrate it.
I can't hear it, Jesse.
Okay, perfect. So you're taking any commodity camera, mounting it above a workstation, a workbench, a work surface, or a work area. This is the Kaizen Copilot tool itself. When you capture video, you're going to label, provide some metadata for that video. What they're going to do is they're going to mark the start and stop of a cycle. And what's nice about this is you can upload 50 to 100 videos of a process at a time. And basically you can increase the work capacity output from an individual industrial engineer by setting up multiple cameras and doing 5-time studies at once instead of spending 1 hour at one station and 1 hour at the next station and 1 hour at their next station. So you capture the video, you annotize where the start and stop of the cycle is in that video. If you have multiple cycles, click cycle detection. It will automatically detect the other cycles in that video as well and annotate those as you did the first. Hit analyze, and our system now goes to work. And this is the entry into I guess the magic of Kaizen Copilot is we just eliminated that manual time study. You can see here on the left-hand side, our system used unsupervised video segmentation to break this down into meaningful third related activity steps. We gave names to those steps, and each step has a time study attached to it. So now those time studies are done for that industrial engineer. We've got our MUDA classification for value add, non-value add, necessary non-value add. And so basically that entire exercise is now completed for that industrial engineer. A video is attached to each step so they can review to make sure the accuracy is where it needs to be. They can adjust. To make sure all of the steps line up with the descriptions. And now here we've got your value add and non-value add time graph and chart. You've got your individual cycle times as well with a standard deviation, mean mode, second shortest. And so again, all of this has been done automatically off of a single video upload. And you can see down here, you've got your time studies. If you uploaded multiple cycles, it breaks it down so you can do a comparative analysis. You can even do shift comparisons. Now, this is a big one. A lot of the times it's very common to not know what's happening on shift 2 or shift 3. Shift 1 is the one that's typically dialed in, and then the later shifts in the day are the ones where things start to unravel a little bit. In one of our customers, we found just within 24 hours of doing video capture, we found about 30% of waste that was occurring in shift 3 that wasn't occurring in shift 1 and 2. So you can do shift comparisons to see where the inefficiencies or deficiencies are. And you down here, you've got your step time comparisons. Again, all of this has been done automatic. This is an example of a time studies export. So all of our modules in Kaizen Copilot, the data is exportable, which is another task that's very menial that Zeeshan talked about, is that data collection, putting it in documentation and having the ability to share that documentation. We'll generate work instructions for you, again, automatically. And this is a whole separate, outside of time studies and motion studies, building work instructions is a whole separate manual task for an industrial engineer. So right now it's just going through an audit and compliance exercise to make sure it gives you meaningful and relevant AI suggestions at the end of this, which we'll show you. Simple yes/no questions. Can a tool be placed in a different area? Can a power or portable tool be used instead of a manual tool? And then now this is where the Lean GPT comes into play. So action analysis, the system will look at every step in that process, analyze that step, and give you suggestions that are relevant to that process on what you can do to reduce the cycle time, which results in a cost savings and a time savings for each one of those steps. It will do that on the step level and overall cycle level. Here are the suggestions. It will scroll down. You see it's also performed spaghetti diagrams of operator activities, which is also an extremely manual process for an industrial engineer to do. It gives you Kaizen points that you can focus on for workstation audits, where you can reduce waste, where the waste is occurring, an ergonomic overlay of the station itself to suggest improved economy of motion. And then here is the AI suggestion readout that gives you all of the improvement suggestions with a cost savings and time savings attached. Those can be customized to your facility based on region. So if you have different labor costs per region, you can customize that to make sure you get accurate results. And that's just one module of the Kaizen Copilot. And basically, we just showed you typically what takes 4 to 8 hours to do can be done in a 20 to 30-minute exercise. These are some of the other modules that are included in the Kaizen Copilot. We can automate the line balancing aspect. Again, that was one of the challenges with that cell phone company we referenced. They had dynamic rebalancing that take place shift by shift. So you can automate your line balancing. You can automate your ergonomics assessments, your PFMEA and control plans, your MODAPS MTM codes for predetermined time and motion studies, the station design we just watched, and then generating rich video-based work instructions off of a single video upload. So massive overarching theme is massive time savings. The path to the relevant data is about 1/10 of what it traditionally is utilizing the Kaizen Copilot. And you can see some of these metrics that we've seen in our customers who have deployed this globally over the last year. So 25% increase in productivity, 50% reduction in rework, 40% reduction in lead time, which is massive, especially with the customization, mixed model lines and enhanced configurations, and then an 80% lower risk score. So the time and motion studies without a stopwatch, we showed that in the video. Balance and rebalance lines easily. This gives you a screenshot of what that looks like. All of the videos of these are available on our website, so you can look at the different modules. You can reduce waste and boost yield. This is one of the case studies. We worked with an industrial safety manufacturer, and this was probably a very good example to use. Is they had limited visibility into process efficiencies. Basically, they were tasked by their corporate team to increase yield by a certain percent over a certain period of time. When they reached out to us, they had spent about 90 days in that exercise, had reached about 25% of that yield objective, but have maxed out what they can do internally with their own resources. And we're looking to leverage tools to help them bridge that gap to that corporate goal they were tasked with. And within a matter of days, we were able to identify about 30 to 40% of additional waste that was occurring. We were able to eliminate that. Within a couple of weeks, we were able to get the yield improvement up to about 6%. And by the end of about 90 days, we were able to get that yield to that corporate task. So we were able to get that yield objective in about a quarter of the time that it would have taken them to do if they did it on their own. And we did it with a lot less resources. So here's the results: 43% process waste identified on one line, 20% waste eliminated in 2 days, 5% yield boost in 2 days, maintained output with one fewer operator, reducing labor costs, positive ROI within days, no disruptions to operations. And we have a customer testimonial video available on request for this specific case study, so you can see firsthand what those results look like. So every 1% yield improvement flows straight into EBITDA. AI links operational metrics directly to financial outcomes, and typical deployments pay back in under 30 days. You don't get that anywhere else. AI-driven visibility enables smarter capital allocation and cash flow stability. We can start small. We can scale as fast as you need it. We can prove the ROI with measurable savings at every step. This is not a system that takes 3 years to transform into measurable results. This is functional AI that you can drop in your facilities today and start seeing that ROI the day that the tool is implemented. Going back to the team, Zeeshan mentioned his background. I've also been in manufacturing and spent a considerable amount of time on the floor. Our entire founding and leadership team comes from a manufacturing background, which is very unique in this space. Typically, what you'll see is teams that are purely technical. Our team has that background where we build tools that we know very well. We're very familiar with the problems that we're building the tools for. It also helps us when we're talking to our customers, we actually understand what they're saying to us in the terms of feedback, customer requests, pain points, and challenges, because we've experienced those and again, spent a considerable amount of time on the factory floor. I'll leave this up. And then Elsa, yeah, go ahead.
Awesome. Well, thank you very much, Jesse and Zeeshan, for walking us through all those demos, insights, and examples. So it's time to get into your questions. So if you haven't had a chance yet, feel free to drop your questions in either the chat window that we've got going on or the Q&A panel that's on your screen. It might be hidden in the bottom buttons, and we'll try to get through as many as we can with the time that we have left. So I do have some queued up from during the sessions, so I'll kind of kick us off to get started. Let me go through the first one. So how long does it usually take before companies start seeing real financial returns after rolling out AI? Jesse or Zeeshan, who wants to take that one?
Yeah, I can go ahead and take it. So similar to what we said in the call, our customers see financial impact literally from day one of deployment. Our typical payback across our tools, both tools, is less than 6 months. And the barrier to entry is about 1/10 of what you'll see versus the rest of the marketplace. So when we built our tools, we built them to eliminate the barrier to entry. We built them to be able to stand up very quickly and scale very fast. And we built them so they are functional from day one. And you can see that financial impact from day one, the minute that it's deployed on the factory floor.
Perfect. Thanks, Jesse. Second questions we've got is, do you need to have a certain level of data maturity or infrastructure in place before AI tools can actually start delivering ROI?
I would say that you can start both the tools that we talked about, Kaizen Copilot as well as Assembly Copilot. You're able to deploy those without having any other solution on the floor. If you have ERP or MES, we can certainly integrate with those kinds of solutions as well. But I would even go as far as to suggest that having Kaizen Copilot is one of the first tools, one of the first digital investments that you make is the right thing to do. Simply because it's the tool that will help you set up your processes, help you streamline things, help you standardize how things are done, and open up the way for further downstream digitization initiatives. For instance, your ERP and MES systems. Certainly, we do not need data warehousing or data lakes or anything of that sort. These software tools, both of them, come with their own data models that allow you to store data in a structured way and retrieve it as you deem fit. So in summary, I would say that you could probably deploy these without having much laid out in advance.
Perfect. Thank you, Zeeshan. Next question we've got is, for companies with multiple plants or product lines, how can AI help spot where the biggest opportunities for improvement are?
Right. It's exactly the Kaizen Copilot demo that Jesse was showing. Of course, Jesse, for the interest of time, he just emphasized the individual station level module. We have line balancing, we have spaghetti diagrams at the level of entire cells. We have a bunch of other kinds of modules as well. But it's really, really lightweight. You can use, if you can see my background, you just take a smartphone, you put it on a station, record 10 minutes worth of data, and the AI gets to work. It can deliver documentation to you. It can deliver improvement recommendations to you as well. So it's really lightweight. You can go around your shop floor, capture data, and start generating improvement recommendations, including quantifiable improvement recommendations, quantified ROI estimates. This is where you're going to get the highest ROI, and then you can focus on those stations for your improvement initiatives and improvement activities.
Perfect. Thank you, Zeeshan. I think we've got time for one more, and then we'll wrap it up and get everyone out within that 45-minute mark. So any tips for getting finance and ops teams to actually speak the same language when it comes to performance data?
Yeah, I think it's going to be not necessarily about being able to speak the same language, but I think just bridging the gap because, typically, especially when we're working with an individual facility, or we're going through the procurement process, there's several layers that we have to get through. And each time we get to one, someone's looking at it from a new lens, right? Which is why it's important, obviously, to have a champion at your company for tools like this. But from a finance perspective, I think it's extremely important that you become a little bit more aggressive on learning about the tools out there that can not only make your manufacturing floor's jobs easier, but your job easier as well, because this eliminates workflow for you too. And so being proactive and speaking with your facilities, saying, are you using tools like this? What have you looked at before? Are there things that you're interested in using? How much budget do we need in order to get some of these tools in-house? That's what I would recommend is just a little bit more proactive approach, or at least being involved early on. Be willing to be looped into the conversations early on so you're aware of the tools and solutions that are being evaluated.
Thanks, Jesse. I know I said that was the last one, but we just got one more in, and I do want to get to that one. So are there multiple sales package slash modules? Kaizen, assembly, etc. Are there more?
Yeah, our plans are completely customizable to each facility and your specific needs. So we can do an assembly Copilot package, we can do a Kaizen Copilot package, we can do a hybrid of both. It's just based on those needs. And typically we just need to have a conversation to learn more about your applications and we can put something together for you.
Awesome. Thank you. Well, that's it. Well, thanks everyone for joining us today, and special thanks to Jesse and Zeeshan for sharing your time and your expertise. And just a quick reminder, today's session was recorded, and you'll be getting the link in the next day or so, including the ROI calculators that Jesse had mentioned, so that you can use them to estimate the return for your own scenarios. When the webinar ends, you should see a short survey that will ask for your feedback. We'd love to hear from you and what you thought about today's session and what some other topics you'd like to learn about next time. If you'd like to learn more about retrocausal or any of the AI solutions that you saw today, visit us at retrocausal.ai or send us an email at demo@retrocausal.ai, and we'll be happy to chat. Thanks again for spending part of your day with us, and we hope to see you at a future webinar. Have a great rest of your day.
Thanks, everyone. Thank you, Elsa. Bye.